On example number 2, we have 2 logs on the left-hand side with the minus in between is equal to 2. Go ahead and pause it. Try it yourself. Try working out example A and B, and then we can check answers. Go ahead and pause it. Great. So first, I'm going to go and condense this. I have 2 logs. I'm going to condense it into 1. So I'm going to combine like terms in a sense. And because there's a minus in between, they are going to divide. We're going to divide x squared plus 4x divided by 3 is equal to 2. Now I can get rid of the log. I'm going to go ahead and exponentiate both sides with base 2. That will cancel. That will give me x squared plus 4x over 3 is equal to 2 to the second power, which is equal to 4. I'm going to go and cross multiply. I'm going to place this over 1. Cross multiply. That will give me x squared plus 4x is equal to 3 times 4 is 12. Now I have a quadratic equation, and I'm going to go and continue on the left-hand side. I'm going to go and move my 12 to the left, becomes a negative. So that's x squared plus 4x minus 12 equal to 0. And now I can solve it by factoring. I can complete the square, but I think factoring on this one works fine. That'll be x and x. Factors of 12 will be 3 and 4, 6 and 2. So 6 is positive, that's a negative. To solve it, I'm going to use my zero product property. X plus 6 equal to 0, x minus 2 equal to 0. Move the 6 to the right, becomes a negative 6. Move the 2 to the right, becomes a positive 2. I want to be able to double check both solutions. Now, let me check the first one. There's no x on this log, so this is fine. The one that I need to check is I want to make sure that whenever I plug in the values of x, that will be bigger than 0. So let's check the first one. X squared plus 4x, we want it to be bigger than 0. I want to plug in a negative 6 squared plus 4 times negative 6 is greater than 0. 36 minus 24 is greater than 0? Yes. Now let me plug in it 2. X squared plus 4x has to be greater than 0. I want to plug in it 2, so it'll be 2 squared plus 4 times 2 is greater than 0. So it's 4 plus 8 is greater than 0? Yes. So both answers are correct. So this answer is correct. This one is correct as well. Let's go to example B. On example B, we have 2 logs on the left-hand side. I want to be able to condense it, so I'm going to combine both logs into 1. And because they are adding, I'm going to be going to multiply. So x times x will give me x squared is equal to 2. Now I need to be able to get rid of the log, so I'm going to exponentiate both sides. I'm going to exponentiate with base 5. The log base 5 and the 5 cancels. So now I have x squared is equal to 5 squared, which is 25. 2 ways of solving this. You can go and move the 25 to the left and factor it, or we can just take the square root. Take the square root on both sides. That will give me x is equal to 5. And don't forget, because you're taking the square root on both sides, it will be plus or minus 5. Now I need to check my answer. Since they both are the same, I can just check it on one. Let's go and check positive 5 first. So x has to be bigger than 0. So 5 has to be bigger than 0, that's fine. X is greater than 0, so let's plug in negative 5. Negative 5 is greater than 0? No. So my only solution is x is equal to 5 is only the correct solution. Let's continue with example number 3. Solve the following equations. We want to make sure that we check for extraneous solutions. I'm going to go and draw the line. I have two logs on the left hand side, I have one on the right hand side. So the first thing, I want to be able to combine both logs on the left hand side. I want to be able to condense it using the product property. So I'm going to have log base 6, and because they're adding, I'm going to go and multiply. So let's go multiply. X times x will give me x squared. X times negative 7 is negative 7x. Is equal to log base 6 of 8. Now I can get rid of the log. It's base 6, so I'm going to exponentiate it, both sides with base 6, and it cancels very nicely. Now I have x squared minus 7x is equal to 8. I have a quadratic equation, so I want to be able to see if I can factor it. So I'm going to make a equal to 0. I'm going to move that a to the left, we can say negative 8. Now remember, if you cannot factor it, then you're going to have to you cannot complete the square because this is an odd number, so you're going to have to use the quadratic formula. If I factor it, this is x, 8 and 1, and this is a negative, that's a positive. X squared, 1 minus 7 is negative 7, minus 8. Now I can do my t-chart. X minus 8 is equal to 0, my 0 product property. Only because this is equal to 0, you can do this. Move the 8 to the right, becomes a positive 8. Move the 1 to the right, becomes a negative 1. Now, I want to be able to double check my answers. Not both of them have to be correct. Remember, we check our answers by plugging in here. Automatically, I see that if I plug in a negative 1 in here, let's go and check. Let's go and use this one first. X is greater than 0. So let's go and plug in negative 1. Negative 1 greater than 0? No. This is not an answer. If I plug in an 8, this should be fine. If I plug in an A in here, that one will be fine as well. But let's go and do the work. Let's check the second number. So it'll be x minus 7 has to be greater than 0. So 8 minus 7 is greater than 0. Is 1 greater than 0? Correct. So this one's fine. Go and try the last example. See if you guys can do it by yourselves. And then we can work it out together. Go and pause it. Great. So let me go and draw the line. They both log. Remember, if there's no base, automatically there's a little 10 in there. So we're going to condense it into one log. And because there's a minus in between, we're going to divide 4x minus 5 divided by x is equal to 0. Now, I want to get rid of the log, so I'm going to exponentiate both sides to base 10. That will cancel. We have 4x minus 5 over x is equal to 10 to the 0 is equal to 1. I'm going to divide it by 1, or just place over 1 so I can cross multiply. 4x minus 5 times 1 is 4x minus 5. X times 1 is just x. I'm going to go ahead and move my 5 to the right, becomes a positive 5. My x to the left becomes a negative 1x. So that gives me 3x is equal to 5. Divide by 3. X is equal to 5 over 3, or 1 2/3. We need to be able to check. So I need to plug in 5/3 in here. We know that that works because that's going to be positive. But let's go and double check on the 4x minus 5. We know that 4x minus 5 has to be greater than 0 because we cannot take log of 0 or we cannot take log of negative number. That will give you an error. So 4x minus 5 has to be bigger than 0. So 4 times 5/3 minus 5 has to be bigger than 0. That'll give me 20 over 3 minus 5 greater than 0. 3 goes into 26 times. We have 2/3 minus 5. Is that greater than 0? Correct. That'll give you 1 and 1/3 and 2/3. So that will conclude the lesson for today. Please email me if you have any questions, and have a great day.